Well, good morning and welcome wherever you are. Maybe it's good afternoon. Actually, I know we got some people on the East Coast here, people from all over the United States here. Welcome to this Heroes Tour at Beam Global in uncharacteristically cloudy and kind of wet and rainy San Diego day here. Although I must say that's a very good day for us to talk about our products because they're all still working even though there's no sunshine. So I'll come back to that in a second. But yeah, first and foremost, I'd just like to welcome you and thank you very much for what you're doing. Obviously for being customers for Beam Global, that's very important to us, but also just in the broader sense what you're doing in terms of your efforts to help electrify transportation and particularly have your fleets and your vehicles driving on sunshine. Transportation and the generation of electricity account for about 2/3 of the greenhouse gas emissions in the United States, and actually globally that's a pretty good number as well. And so whenever you're using our products, you're essentially wiping out both sources. So this is just a fantastic business that we're involved in. We're delighted to have all of you involved as customers and as people who are to whom we're delivering product. I'm Desmond Wheatley. I'm the President, CEO, and Chairman of the Board of Beam Global. We are a San Diego-based sustainable technology innovation company. We invent products, we take them through the patenting process, we design and engineer them, and then we actually manufacture them here in California as well. So this is a made in America, made in California product. Don't let my funny accent fool you. I'm a new American, very happy to be here, and I love this country. It's been good to me, and I hope I've been good back to it as well. And actually loving the country is a big part of the reason that I'm doing what I'm doing. Spent a lot of time in the Middle East. I've looked at the pre-electrification industries, and frankly, I'm really looking forward to another century of American leadership where we're in control of our own energy. We're not relying on other people for it, and it's clean and green, and again, allowing people to drive on sunshine. Just very hard to be better than that. So I'm standing in front of our 53,000 square foot facility. I'm about to take you through a tour to show you how we make the products. But before I do that, just a couple of housekeeping items. I do want to let you know this is entirely unscripted and unrehearsed. In fact, I just ran down here having finished a meeting, so I'm just rapidly trying to gather my thoughts together to do this. But because it's unscripted and unrehearsed, you should expect that I don't know what's going to happen, and as a result, I don't know exactly what you're going to end up seeing here. We are in Miramar, California, which is just north of San Diego, and we happen to be directly in the flight path of the Marine Corps Air Station Miramar, which is tremendously exciting, but it does mean that frequently we have lots of fantastic pieces of equipment flying over directly over our property here. So F-18s and F-35s, F-22s amongst a bunch of rotor aircraft as well. So those things are very loud. It's not a good idea to try and compete with them on any level. Certainly our adversaries know that, and you'll discover that as I'm talking to you, if they do fly over, I'm probably just going to end up stopping talking because it's useless to try to compete with them in any sense. And if you see me doing this and I'm not talking, it's because something's flying overhead. So just let you know that. Beyond that, we're going to be in an active working environment. There are trucks coming and going all the time. And so I'm going to be trying to make sure that I don't fall over anything. And also Lainey, who's standing behind the camera right now, she's looking at the camera and not looking where she's walking. So don't be surprised to see me telling her to watch her step. Okay, before I take you into the factory, I'm actually going to take you on a little history tour because our parking lot's a little bit of like a sort of museum here. Beam Global's been in business since actually 2006 originally. I took it over in the third quarter of 2010, and we were called Envision Solar for a little while. Then we rebranded to Beam Global because we're so much more than a solar company. We rebranded 2 or 3 years ago. I love the name. I'm very much in favor, and the marketing team did a wonderful job where that's concerned. But what I'm going to do is I'm going to show you some of our very earliest products here, and actually the kind of the progression of it. And we're going to start off, Lainey, if you just follow me, we're going to start off here in the parking lot, and I'm going to show you unit 003. So this will be the third one we ever made. The first two went off to customers, so we don't have that. But we kept the third one we ever made, and it's operating here in our parking lot. Now, Unit 003, we've made tremendous improvements since we made this first product here, and the newer ones that we're making now are much more powerful, they have much more storage, and they perform better in many, many ways. But I'll tell you what's really crucial about this, that product that we made back in 2011, so it's 12 years old now, or 2012 I think it was, so it's 11 or 12 years old. It's still operating today with no appreciable degradation in its performance. That means to say it's still generating electricity, it's still storing electricity, and it's still providing electricity to the cars that are plugged into it in more or less the same way as it was when we made it over a decade ago. And I'll tell you, that's more than I hoped for. When we first started making these, we assumed that the batteries might have a life of 5 years and that we might have to go and change them out. We deliberately set them up to be hot swappable as a result of that. But the truth is we've never had to swap out any batteries. And this is living proof of it. This product here has, again, been in operation now 7 days a week, 365 days a year, regardless of the weather conditions or anything else like that. And it's still operating with no appreciable degradation in its performance. So we often talk about the EV ARC being a 20-year product. And people say, well, how do you know that? You haven't had them in operation for 20 years. Well, of course, we've done some testing and we've looked at some of the other aspects of it. There's lots of data that we can pull from to support that. But now we can certainly say, without a shadow of a doubt, that we've had them operating in the field for over a decade. And that gives us a great deal of confidence in the modeling that we've done to suggest that they'll operate for longer than that. So we're proud of her. So there's plenty of things that we improved. In fact, I sort of shudder when I look at the very early models, some of the things that we could have done better at the time. But this is a typical product evolution. We're no different than anybody else. It's getting better all the time. But if you happen to own one of the very earliest of the units that we ever built, it doesn't matter, it still charges cars. Yes, the ones we're making now are better, but this is still charging cars in exactly the way it was designed to do back then. This one here, unit 007, we'd made some changes to it. It was more powerful, had more storage in it and all that sort of stuff. 007, I had to keep that. No points for guessing why I kept that unit number. We've got that one in our parking lot here. And although it may look very similar, there are actually some significant changes to it. Now, I'm now going to take you over and show you one of our latest, what we now call EV ARC 2020. And there are some really crucial differences. Now, this is what all of you are getting. If you have an order in with us at the moment, or if we've delivered to you anytime in the last couple of years, all of you have received the 2020 model. By the way, for those of you who have orders into us at the moment, we are ramping up production. I'm going to show you that inside the building. I apologize if we're taking a little bit longer than you were hoping for us to get the product to you, but believe me, we are ramping up like crazy, and we're producing product faster than at any time in our history, and we are not ignoring you. We're coming to you as fast as we possibly can. But let's just talk about this now. In particular, I want to talk to you about how the product's advanced. So just going through it, above me here, I have this solar array. We're converting sunlight into electricity up there, and then we're storing that electricity inside this enclosure area. But this is one of our units the engineers use to test things on property. So we're constantly making sure that everything's working well and as well and better, frankly. But also, as you can see, employees plug their cars in. This is one of our employees here. This is my motorcycle. Plugged in and charging while I'm talking to you. One of the 3 really stupid things that I do. I won't bother getting into the other 2, but I love riding that bike. American motorcycle, by the way. At any rate, we're storing energy up here in this enclosure, and then there's a lot of electronics and computing and other things that go into getting the sunlight that we've converted into electricity into a usable format to where we can deliver it through an off-the-shelf EV charger. Very important to point out, we don't compete with the electric vehicle charging companies. This is a juice box charger made by a company called Enel. We equally do ChargePoint, Blink, Electrify America, you name it. If there's a quality EV charger out there, it's operating on one of our units somewhere in the United States or internationally. We don't discriminate where this is concerned, except to say that we only put what we believe to be quality EV chargers onto these units. But what we're actually doing here is we're replacing what would need to have been done to get this charger working in this parking space. I can tell you the electricity available for it's 200 or 300 feet down there on the other side of the building, which mean we'd have to have trenched the parking lot, poured a bunch of concrete, gone through a lot of very complicated permitting and all sorts of other stuff like that. And it takes a long time to do that, and it's disruptive. We don't want to dig up our parking lot and have it taped off and all that sort of stuff. Drop an EV ARC in a parking space, we get the same results without having to go through all of that. So again, generating electricity up here, turning it sunshine into electricity, storing it in our own proprietary batteries. We make our own batteries now. We didn't for the first several years, but we acquired the company that from whom we've been buying the battery technology. So now we're making our own batteries as well. That's speeding things up for us and allowing us to make the product better as well. And then that electricity comes down through the column and it's delivered, as I said, to an off-the-shelf EV charger like here. There's also an emergency power panel up there. That's an optional extra, but most of our customers do opt to take advantage of that. And this is for situations where there could be a blackout or a brownout. In California, we have what we call flex alert when everybody turns up their air conditioning and during a heat wave and the power company is going to turn the power off or down. This will continue to provide vital electricity during those sorts of events, or if you have a weather event, a hurricane or something like that, there's a blackout, goodness knows what else. We know the Russians have hacked the grid, we know the Iranians have hacked the grid, we know the Chinese have hacked the grid, so that we never know what's going to happen, but we do know these will continue to provide electricity during those sorts of events. So that's very useful part of the product, and of course we'll continue to charge cars during those events as well. And then coming down here, if you look at what the vehicle's parked on, this part, and I'll show you more detail when we go inside the factory. This is the engineered ballast and traction pad. And this thing, frankly, it's the dumbest and the smartest part of the whole invention. It's because of this that we're able to just put this thing down in a parking space and do no on-site work whatsoever. We don't need to trench. We don't need to pour concrete. This is not glued down. It's not bolted down. It's just gravity and its footprint that's holding it in place. The whole product weighs about 10,000 pounds and almost all of it's in this ballast and traction pad. But what's crucial about this is, notice that we have not reduced your available parking. And that's really a major differentiator for us. It's a big part of the many patents that we have in the product. The fact that we have our ability to deploy these things in a parking space without reducing available parking. You know, there are other solutions out there. You could put a container or something, a shipping container with solar modules on the roof, batteries inside it and everything like that. But then you can't use the parking space anymore. And the other thing is shipping containers, 20 feet long, they usually stick a couple of feet out into the drive aisle, which is not, we don't think is a brilliant idea either. So this is a really important part of our innovation and of our patents, is the fact that we're able to deploy this without construction, without on-site work, but crucially, without reducing your available parking space. Parking spaces are valuable. One other thing just to point out while we're here, it's leaning, it's right now tipped up towards the east. And that's because that's where the sun comes up. If there was any sun today, that's where the sun comes up. And it's going to track during the course of the day around through the sky. As the sun goes across the sky, the solar array will follow the sun as it moves across the sky. And it does it in a very unique and specialized way. We have a patent on that as well, because the solar array, while it follows the sun moving across the sky, doesn't leave the lineal alignment of the parking space. So we don't have a problem with, you know, swinging out into drive aisles or into adjacent parking spaces or anything else like that. That's a crucial part of the invention and something that we're frankly very proud of. Now, why is it important? Well, because it gives us about 25% more electricity generation when the sun is shining. 25% more electricity generation, of course, means 25% more miles being delivered to the electric vehicle itself. And so at the end of the day, that's the only thing that's important. People love talking about kilowatt hours and solar technology and all that, but the only thing that really matters is how many miles can we put into this vehicle. And a unit like this is going to generate and store enough electricity to provide up to 265 driving miles in a day. Doesn't matter how many cars you plug into it. We're really focused on what we call daily range replenishment. So we strongly advise you to plug your vehicles in anytime you can, whenever they're parked. We don't want you, but you know, if you have a Chevrolet Bolt, for example, that has a 270-mile range and you're only driving 20 or 30 miles a day, don't leave it for a week to plug it in. Plug it in every single day. Better for the car, and certainly much more useful for this, because this is a solar powered unit and it is storing the solar energy. If you leave it for a week, once the batteries are full up, then all that solar energy is being wasted. You're losing the solar resource. Whereas if you plug in every day and you take a little bit out of it, think of the batteries like a bucket filling up with water. You take a little bit out, then we can fill it back up again. You take a little bit out, we can fill it back up again. If you let the bucket fill up and you don't take anything out of it, the water just spills out everywhere. That's really how the batteries are behaving with the solar electricity that we're putting them into. So please use it every day. In fact, every time you park, just plug the vehicle in, keep it topped off all the time. It's not going to hurt the car. In fact, it's probably better for it, and you're going to get a lot more out of the infrastructure as well. So daily range replenishment, really like that. I've been doing it myself for 12 years. The idea of going somewhere special and hanging around and waiting for a charge, no matter how fast it is, I would never do that. My vehicle, as you've just seen, is charging while I'm talking to you. And then the last point I'll make while we're out here is just that. My vehicle's charging while I'm talking to you. Look at the conditions. The sun's not shining. It's raining actually right now. It feels like I'm back in Scotland, not San Diego. But at any rate, products designed to work through those types of environments. It is solar powered, so it does need to see light. But even on a day like today, just as you can get a sunburn on a cloudy day, we're actually generating some electricity right now, even on a cloudy day like today. But the batteries will tide us through here, particularly if we're plugging in every day. And we're not trying to exhaust the unit by filling up an empty Tesla and then trying to do that again. We want to be constantly taking energy off it, allow the solar to bring it back up, take energy off it. So daily range replenishment, or even periodic range replenishment. We have some customers who will plug their cars in several times a day, and that works really well for them. Okay, I think that's it for out here, and we've managed to do that without any trucks running us over, although here comes one now. Let's go inside the building, and I'm going to show you how the magic happens, how the product's made. I'm going to walk you through what is actually the sort of the end of the story. So we're just going to walk through this part of the building right now, and then we will come back here in a few minutes and show you what the end of the story is. So we'll just run through here. There's sort of three main areas to think about where the product is concerned. There's a structural element. This is the thing that allows us to deploy these things. Watch your step, Lenny. Thank you. Okay. There's a structural element. This is what allows. By the way, is now rated to survive 160-mile-an-hour winds. A very robust piece of kit. It has, in fact, survived 185-mile-an-hour Category 5 winds down the Caribbean. So we give it a rating, which it's stamped for, to survive 160-mile-an-hour winds, but we know that, in fact, it will do more than that. There's a bit of overhead in there because, in practice, we've seen it actually happen. It defied even my expectations. 185-mile-an-hour winds, incredible. I went to sea when I was a young man. There was a couple of instances where I was in winds of over 100 miles an hour. It takes your breath away, literally. 185 miles an hour, just astonishing, but our product survives it. The other thing that's really worth pointing out is that the product is also flood-proof to 9.5 feet as well. So if you're in a flood zone, which people increasingly are now, next to rivers or up hills or whatever, or next to the sea or whatever else, hurricane comes, storm surge or whatever else, or flooding, that product will survive that inundation up to 9.5 feet. When the waters move away, you can continue to charge cars. And by the way, when the waters are there, you can still use the emergency power outlet as well. So that structural part of the product manufacturing is taking place here. And we've got a whole team of people here. In fact, we're adding a shift. Again, for those of you who are waiting for product right now, we're adding a shift here so we can further increase our production. But if I just take you over here, stand on this here. This is that base pad. This is the thing I described as the dumbest and the smartest part of the invention. They're actually working on this right now. They're welding the elements into it. It's structural, it's curved, it has a camber on it. That makes it stronger. It also makes water rush off it, and it doesn't accumulate mud and things like that. But this part here is really the first and most important part of what they're doing. And we're bringing raw materials into this factory here. And then our team of welders and fitters and engineers and all the other people like that are forming this into the actual structure, which ends up building the product. So you look at 1, 2, 3, 4 right there of those units. This yellow structure here, by the way, is an indication of our continuation of adding tooling. And so at the moment, there are some processes that we're doing manually. This will automate some of those processes. And again, that allows us to get more product out of the factory faster as the demand for electric vehicle charging goes up. This chap over here is working on some of the column elements. You can see here, 1, 2, 3, 4, 5, 6, 7 columns right there. Each of those will be going onto EV ARCs, which will be leaving here shortly. And then, Delaney, if we just wander out here, what you'll see stacked up out here, if you can see that over there, all of these components here stacked up, they've been completed. Those are actually the solar arrays themselves. That's the thing that's going to go up in the air. The solar panels are going to go up there, and that's what's going to convert into sunshine. These stacks of these, they're all getting ready to go off and get painted with marine coatings. And then when they come back, they'll they'll go into the remainder of our production process. In fact, I'll show you what they look like when they come back. If we go through here, each of these is going to be abraded, sandblasted, and then coated with a marine grade coating so that it should survive the harshest of circumstances. Oh, but before we go out, one other quick thing. Let me just show you this. This white trailer that you're looking at here, this is what we call ARC Mobility. ARC Mobility is a specialized transportation system. This allows a single individual to move EV ARCs around. They fold down and in upon themselves like this. And then you can take them to another location with this thing, and the hydraulics will open the system up. Some of you may have seen that when we've deployed these here. So we make these too. We originally thought we would use them only ourselves, but of course, it turns out that our customers value the ability to move these things around as well. So many of our customers now own ARC Mobility trailers, and this one's going off to one of you here. Looks like it's nearly finished, and then we'll get the next one out. Dude, a bit loud in here. Okay, so when the steel work's finished, those components, as I say, they leave here and they go off and they get abraded and then they get painted. And then when they come back, this is what it looks like. I showed you that stack that was out there. That was prior to paint. This is what those same things, exactly. These are the solar arrays look like when they come back from paint. There's actually 3 sections to every solar array because they fold in and down on themselves, and I'll show you that in a second. And these are stacked up. They're waiting to go inside the building to get the solar modules stacked on them. And then I'll just nip across here and show you. And then these are the base pads. So 1, 2, 3, 4, 5, 6 base pads here. Again, the dumbest and smartest part of the invention stacked up on this. These have come back from paint now. They have a non-skid surface on here. So you don't slip on them, and so that the tires grip them when you're parking on them. The column's already there waiting to go on, and the pedestal and everything. And this again is waiting to go inside the building to have all the electronic components and the brains and the energy storage and everything else like that put on there. Now, I'm going to show you that process, but actually here, there's a couple of them that are in complete conditions here. You'll see they've already been folded down, but the column has not yet been folded down. These are getting ready to ship out. If you look at over here, you can see another one on the back of our truck there. That's going out of here as well, so obviously ready to ship right now. So there's several methods that we use to deliver these things. We can either put them on that trailer that I showed you inside, or sometimes we will also put them on the back of our trucks here and deliver them on the back of the trucks, and the truck can unload it and into the parking space. Or if we turn round, this is another method here. This is actually this is an independent carrier. This is not us. So this is one of our customers with an independent carrier who's coming in, and they'll be picking up 2 units here today. We fit 2 of them on the back of this flatbed trailer here. He'll get loaded up. The units, you can see where it's marked out in yellow here. That's where the EV ARC units get placed, and then these will get lifted onto this truck, and then the truck will go around the building and leave and head off to a customer wherever across the country. And frankly, I don't know where it's going, but it's going to one of you. So they'll bring the second one out as soon as it's completed, they'll load it on, and then he'll go out there. So yeah, you see this common carrier type of approach that we're doing here, where it's a third party who's delivering it, or we're delivering it on our own trucks and our own equipment, or we're using our own ARC Mobility trailers to get them out there. So the variety of different ways of doing it. Oh, what you're not seeing here, because we're not doing it this minute, but they also go inside a shipping container. So we can put 1 EV ARC inside a 20-foot shipping container, or we can put 2 inside a 40-foot shipping container and ship them anywhere in the world. Okay, so that's what they look like when they're complete. Yeah, I probably should have dwelled a little bit more on it. You can see what's happened here is the column now has folded down and broken in the middle. The sides have folded in, and that gets this into this really compact condition here to where we can ship it either in a shipping container or legally down the highway. Obviously, shipping it when it's up with the array and up and all that sort of stuff, that's not going to be a brilliant idea. Although we have moved them around like that before. But it's much better, this new thing that we do now, and get this condition down here where it's nice and compact to go down the highway or inside a shipping container. And again, you can see the emergency power panel built into the enclosure there. So a nice view. And then here's the charger. So the charger's already installed. Obviously, this piece will come off when it's delivered, and the thing folds out and it's all bolted together. But ready to operate, basically. We deliver with full batteries. So when the thing arrives on site, should be able to charge the vehicle immediately. Right, let's go back inside the building here. Here's some of our enclosures. These are the actual things that protect the electronics and the batteries. They're getting ready to come in here. This is a test bed here. So we do a lot of testing. We're in a constant process of testing and engineering the product, see how we can improve things and make things better. That's a test bed there. And now we're in the final assembly area. So this is where everything comes together. Again, if we go back to this, remember I said we had a structural element to this. We've got a generation element, we've got storage element, and then we've got electronics. Well, it all comes together in here, in this part of the building. On the other side of that wall, we have another space which is just like this one. That's where we do all our electronics work and storage. We're not going to go in there today because there are things that we don't put out in the public domain going on in that environment, but they're putting all the electronics, and if you think of it as the brains essentially, and the guts that are essential to taking sunlight and putting it into your vehicle, which is a complex process. Seems simple, but it's actually a complex process. Most of the magic that's doing that is going on the other side of that wall. When they're finished with the electronic components and they're finished with the steel components and they've been painted, they'll come in here and they're going to get put onto these workstations. And what you can see here is 6 workstations. This is essentially the bottleneck of the business, if you like. We can only be working on 6 of these at a time. However, staffed, we can actually produce 1 EV ARC per workstation per shift. So we can essentially get 6 of these out of here in a shift when we're staffed to do that. And I'll just take you through what that process looks like, because we've always got some evolution going on here. Yes, so I think this one's the one of the earliest in its stage. Hi, John, how are you, mate? Good. So this one's just come in. It's still got some rainwater on it, in fact. And what John is doing right now is he's actually getting ready to install the column onto the underside of the array. This is the thing that's actually going to hold it up in the air. This piece here is part of our tracking technology. That's what's making this whole thing move and follow the sun as it goes across the sky. Sorry, I'm in your way. When he's finished doing that, he's then going to put some solar modules on the top here. And this one here is in that condition. You can see, hey guys, how are you? They've already started to install the solar modules here. You can see the column is already on there right now with the tracking and everything in place. So once they bring them in here and put them on the racks, they then start installing the solar modules. They're doing the wiring and they're installing the upper column. The next sort of part of that evolution, this one's getting its tracking put on as well. The next part of that evolution, I would say, is happening probably on this one here. They're actually starting to install the brains and the guts. This is energy storage right here. Again, we make our own batteries, and they're installing all of that stuff with all of our special and patented technology inside this area here. So this whole thing is going to follow the sun, move around and follow the sun during the day, including all the equipment and everything. And again, remember, all of that is up in the air. Now, when they're finished this, and this one looks like it's getting close to being finished, because that chap there, he's an engineer, and one of his jobs is to, he's going to connect a computer to the thing. And with the computer, he's going to turn all the systems on and off and run them through a series of tests and do what we call final assembly and checkout. I think FACO is the acronym. I can't even remember what it stands for. But anyway, he's going to do the final checkout, make sure that everything is turned on and commissioned properly before it leaves here. The benefit of that is that when we get to your site, we don't have to do any commissioning. We might have to do some stuff to the charger itself, because that's something that's not really within our control. But the unit itself will be ready to operate when it gets there. And he's going to test all of that, including the tracking and everything else. You can see the computer bank that he has there. It's on wheels. He just goes from one station to another all day long, making sure that all of these units are working. August, everything all right? Good. All right. So when that process is finished and we're sure that it's working properly and that everything's turned on as it should be and that the energy storage is working and that the solar's reporting and all the other things, they will then fold the wings down on the array, and then the crane, which if you can get a shot of the crane there, which is above my head, John's actually using it right now for the column, but when he's not doing that, the crane will swing back over, grab that array, and then what they call it flying it. They're going to fly the array, and they're going to bring it down here, hanging from the crane, and they're going to drop. They're going to swing it in above here. This is the base pad, the dumbest and smartest part of the invention here. They're going to swing it above here, and they're going to connect the hinge point up here with this upper column here. And that will all get set up inside this building here. They're going to do a few more tests on it, make sure the tracking and everything's working as it should be. And then they're going to fold it down and in on itself like this, and it's going to go out the door, and it's going to look like those ones that you saw out there on a truck, on the back of our trucks, or on the trailer, and head off to a customer. So this is a process that's happening all day long, every day. Again, we've just added another shift in this part of the building so we can get more product out of here as fast as possible. And it's a constant cycle of process. As you can see, their EV ARCs in different stages of their evolution, all the way from having just come in from outdoors, still wet with the rain, through having the electronics installed, the solar panels installed, and then the brains and the guts installed, and then the final checkout by the engineers that come onto them and make sure that everything has been installed correctly before they leave the building. Okay, let's see, how are we doing for time? So that's basically the story. You saw the steel work happening, you saw the things coming back from paint, the electronics are taking place in that. It's all coming together in this part of the building here, and then as soon as they fly the canopy with the arrays and everything onto it, on top of that unit, out the door it goes, onto a truck, and then off to your site. Great. One thing I should be remiss of me not to mention the team. We've got a fantastic team of people here. It's a fantastically diverse group of people. We do hire veterans. That's why if you can get a shot of the various flags, what you're going to see is everything. For some reason, we can't manage to get anybody from the Air Force. I don't know. We've got Marine Corps, we've got Navy, we've got the Army, but Air Force has eluded us. So if you're in the Air Force and you're looking for a job, give us a call because we need another flag. And very proud of the team. Very fantastically diverse team. Immigrants, God knows I'm one. As I said, veterans, workers with disabilities, but it's a meritocracy. Nobody's here because of any of those things. They're all here because they're excellent. I'm very proud of them. I feel really great about them. And a growing team too. We have about 3 times more people working for us now than we did at the beginning of last year, because the demand for the product shooting up so quickly. So it's great. People are learning skills, we're training, and we're growing the business. I'll just take you through here now for a quick second. This is one of the fun parts of the building. So what we've got going on here is a lab. Morning, chaps. So this room's full of engineers, and what they're doing is they're testing various aspects of the product. They're testing various aspects of the guts and the brains that go into the product. And they're doing all sorts of different tests to see how the product will behave in different environments and see how we can improve it. This thing, a lot of heat coming off this right now. This is a resistor bank. It's actually mimicking the load of an electric vehicle. So we don't have an electric vehicle in here, obviously, but when you plug in an electric vehicle, it creates a load, and this will mimic that. And then we can plug in all sorts of different things to it to see how they behave when an electric vehicle does plug in, because after all, that's what we're trying to get done here, is charge cars in the most efficient and the best possible way. So the more testing that we do, and the more these people who are much cleverer than I am work on all the various different aspects of this, again, constant improvement, constant risk reduction with the product, all the way to testing the battery. These are our batteries here. They're testing our batteries to make sure they're okay. They'll run through freezing environments. They'll run them through heated environments. They'll do all sorts of other things just to see how they're going to behave. Because when the product leaves here, it could be going to, the desert in Nevada where we've got 120 degrees in the summer. It could be going to somewhere in the Midwest where we've got minus 40 degrees in the winter. The product has to operate under all of those circumstances. And so we're testing all of those various different aspects of it to make sure that it does what it's supposed to do, even in those extreme environments, including hurricanes and everything else. Right. With all of that said, I think we can pop upstairs. And thanks, guys. And I think we can... taking the back stairs here. We'll head off to my office, and I'll answer any questions you have. Through the most important room in the whole building.
There, Desmond.
Most important room in the whole building, the lunchroom. By some extraordinary coincidence, somebody selected a Scottish flag to put up in here. I don't know how that could have happened, but there it is. Okay, just now we're up in the top of the building. Lisa's our HR. Sales here, it may be out. I think is it ACT at the moment? Yeah, so many of our salespeople are at ACT. Accounting, some marketing, CFO, more accounting, more engineering, operations, room for expansion. And then we've got our marketing. Hey, Sandra, how are you doing there? And then we've got a conference room in here, and then service in here. So that's it. Now you've seen the corporate overhead part of the building, if you like, and then we'll come into my office. I'm the big cheese, so I get a corner office, or so they tell me anyway. With all of that said, that's the factory. Thank you very much for spending some time going through it with me and for meeting some of the people down there. And now I'll be delighted to answer any questions that you have.
Desmond, can you hear me?
Just about. By the way, the other thing you should know about me is I'm partially deaf, so you'll have to speak up.
Well, I want to let people know in the webinar that you can answer or put your questions in the Q&A area. So if you move your cursor, a little bar should pop up, and there's a Q&A button on that bar. Go ahead and enter your questions in. We have a couple already, but enter more, and we'll get those answered. So Desmond, the first question is, how long does it take to make one EV ARC?
Yeah, so that's a very good question. So as I mentioned when we were down below, we're at the point now where those 6 workstations that we have there, each of those is capable of producing an EV ARC in less than a shift. But it's a bit like making wine. Just because they're finishing the EV ARC in less than a shift, it doesn't mean that the entire process takes a shift. What you saw when we were on the other side of the wall, where the steel is being made and then the process to coat it and everything else, these things are all happening in advance of that. So from when they first actually start laying down steel to the time that they actually deliver the product would be longer than a shift. It's days, and in some instances even can take a couple of weeks for that process to take place, depending on how everything's stacking up around here. But the key thing is the cadence, because we're constantly building in advance of that. Previously, we didn't ever do any work at all until we'd sold the product in the days when we were doing lower volumes. But now the team just works and produces constantly. So there's a constant flow of material through the building. And really, as it comes down to that bottleneck there, those 6 workstations and how many units we can get out there. Obviously, when we get to the point where all 6 of them are producing a unit a day, we'll add a second shift, and then we can go to 12 a day, and then frankly a third shift, and we can go to 18 a day. But it's a process. But the bottleneck is that last day down there, and as I say, they're doing all of that work, bringing everything together: the steel, the electronics, the storage, the solar, and all that sort of stuff happening in less than 1 shift, just slightly under a shift. And it's that's as I tell the operations guys all the time, that's the to beat number. They got to get better and better at that. With 2 caveats. Nothing that we ever do here in terms of speeding up or moving more product through the factory will come at the expense of safety, number 1. I tell the team all the time, we do all hands on deck meetings from time to time. I go down there and talk to them, and I tell them I would not trade 10 years of profit for the end of one person's finger. I mean that sincerely. I wouldn't. So safety is without a doubt our number 1 focus here. And then right with it is quality. So doing things faster does not mean doing things with less quality. You may not reduce safety or quality to speed up the process, but beyond that, it's everybody's task to speed it up.
Okay, good. Thank you. Next question. How do I know if sun tracking is working?
The best way by far is just to observe the unit. Now, obviously, the sun moves quite slowly across the sky. I often sort of joke it's a cure for insomnia. You want to watch a shadow moving across the ground or something like that. It's going to move quite slowly. So if you're just standing staring at the array, you might have a difficult time ascertaining whether or not it's moving. Certainly, just looking at it periodically during the day, you will see it move, just as the sun moves across the sky. A couple of other things you can do to figure out whether or not it's tracking is you know where the sun is. You know where east is. The sun's going to be in the east in the morning. It's going to move through the south at lunchtime and over to the west at the end of the day. So just have a look at the array. Is it leaning that way? Now, EV ARCs can be deployed in any point on the compass, so they don't have to be north, south, or east, west, or anything else like that. So it's not that it would be in what we call a mouth open condition like the one I showed you. That's just because that unit is east west, and so in the morning it's going to be mouth open, in the evening it's going to be mouth closed. You might have one that's north south, and so in the morning the array might just be tipped to the east, and then at lunchtime it'll be mouth closed, and then in the evening it'll tip over towards the west. But yeah, just observing it during the day, see is the face of the solar panel pointing approximately to where you think the sun is in the sky. Don't look at the sun, by the way, but is it pointing approximately to where you think the sun is in the sky? And now there's one other thing that you can do. The way the tracking works is it's not a constant movement. Every few minutes, the computer sends a signal to some electric motors which turn some gears. And so every few minutes, the computer says, okay, the sun's moved a little bit, you need to catch up to it. And if you're standing under the unit, you will actually hear although it's kind of faint, you will actually hear a kind of a woo, 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 woo. And that's just the motors doing a soft startup, running through their process of reorienting the array and then shutting back down again and waiting for the next command to come from the computer. So those would be the three ways. Does it move periodically during the day? Do you notice a change in it? Is it pointing approximately to where the sun is? And if you really want to get detailed, stand underneath it in a quiet environment, and you'll probably hear those motors turning every few minutes.
Excellent, thank you.
But I'm sorry, just to finish up on that, Sandra, before you, there is another way. We monitor that. We get telemetry from the unit, so we're monitoring that. We can tell whether the thing's tracking or not. So worst comes to worst, you can call your specialist that you deal with here, and they can have a look at it for you and tell you if it's working remotely as well.
Yeah, good point. Thank you. Another question, actually more of a comment. Wonderful presentation. Can I get a copy of the video for my colleagues who were not able to attend? And yes, we are recording this, and we will make sure to send everybody who's on this webinar and who registered access to the video. Next question. My unit has a red light on it that sometimes is on, and it says solar power by that red light. What does that mean?
Yes, okay. That means the unit's working. It's doing what it's supposed to do. If you cast your mind back to when we were down below, I mentioned the fact that it's a solar-powered unit. We're turning sunlight into electricity, we're filling up batteries with that electricity, and then we're dispensing that electricity into your car. And it really does behave very like water. If you want to use that analogy, think of a hose pipe running into a bucket. Bucket fills up. From time to time, we tip some of that bucket into the car. That's what we're doing with this thing. It's possible to exhaust it. What that means is it's possible to take more electricity out of it than it is generating or storing. And there's several ways that can happen. One of them I illuminated already when I was down there, which is that you just leave the unit alone all week, and then you plug in an empty Chevrolet bolt, and then you try and plug in another empty Chevrolet bolt. You will take all of the electricity out of the batteries, and the solar won't have enough time to keep up with it. That's why we really want you doing that daily range replenishment. And we want you telling everyone that's on your team not to wait. Plug in all the time, because we want you taking power off the top of those batteries so that the solar can fill them back up. That way your car's always full and you're not impacting the EV once a week or something like that and taking a huge load out of it. You're just taking a constant load out of it, taking advantage of the sun every day, all day long. There are other instances, though. We're deployed in some parts of the country where you might see weeks on end of very, very, very bad weather. I mean, when I say bad weather, like Scottish type of weather, dark skies, raining and all that, and all that sort of stuff. So we're getting very little solar resource under those circumstances. The unit's still working. It's still going to charge, car's still going to do, but you're going to see that red light. That red light is a signal. It's an indication to you that the unit knows that it's had enough electricity drawn out of the batteries. So now what it's done is it's turned the car charger off. So the way this works is our batteries are designed to protect themselves from being fully drained. They'll allow you to charge a car until they get down to a certain level, and then they'll turn the charger off and wait for solar to replenish the batteries. And we do that for a whole host of reasons. First of all, it's good for the batteries to manage the batteries in that way. That's one of the ways that we do not need to swap them out. As I told you at the beginning, we thought 5 years we would get out of the batteries. We've got over 10 years now, and the batteries that we're making today are far better than those batteries that we were installing 10 years ago. So we should anticipate at least that lifetime, if not much longer. So yeah, they turn themselves off to protect themselves under those circumstances. You're going to see a red light. They also turn themselves off because the unit itself consumes some electricity. Tracking will continue to work. The computers stay on. If you're in cold environments, there are heaters in there which keep the electronics and the batteries and everything in a comfortable temperature range. So the batteries and electrons are a bit like Goldilocks. They don't like things too cold or too hot. So we have to do a lot to try and keep everything in a comfortable temperature range. And so we're going to keep some power in those batteries to run all what we call the parasitic loads, not charging your car, but keeping the other vital life support systems of the unit operating until it gets a solar resource again. So if you see that red light, plug your vehicle in, walk away from the unit. When the solar resource brings the batteries up, it doesn't have to fill our batteries all the way up. The unit's intelligent enough to know once it gets a certain amount of power in the battery, it'll start dispensing some into the vehicle. The unit's going to dispense some solar into the vehicle, some battery into the vehicle, sometimes solar only into the batteries. And then, of course, nighttime, you're just charging directly from the batteries. And a lot of our customers do charge at nighttime. Fleet vehicles, they operate all day long. They come home like chickens to roost at night, and they're only plugging in at nighttime. So although it's a solar-powered unit, we're doing the great majority of our charging at nighttime. If you do a lot of charging at nighttime, there's no solar resource, then that red light's going to pop on. When the sun comes up, starts charging the batteries again, the unit will start charging it. Most times, you just leave the car plugged in, and it will start charging again as soon as the sun gets enough solar energy into the batteries, and that red light will turn off and the thing will start charging again. If you have some kind of user authentication, a Bluetooth card or something that you need to turn the charger on, you will need to go back to the charger and wand it again or authenticate again, because of course, once it turns the charging session off, it needs to see you authenticate again before it will start charging the vehicle. That's not us, that's just the charger defending from unauthorized activity. But I guess the crucial message here is if you see the red light, it means the unit's doing exactly what it's designed to do. It's defending its batteries in an instance where it's been over discharged or there's not enough solar resource. As soon as it gets a solar resource, it's going to turn back on again.
And we have one more question. So if anybody has any additional questions you want addressed, type them in. Last question at this point is, what about ADA compliance?
I'm sorry, I missed it. Oh, ADA compliance. Okay, I should have showed you that outside. Yes, the unit is ADA compliant. Now, let's be absolutely clear what I mean by that. The actual EV ARC space itself is not ADA compliant, and that's because the solar array can, in some instances, prevent van access, and the van access is an important part of Americans with Disabilities Act compliance. However, we have placed the chargers within the reach height and horizontal reach access required by ADA. And so what you do is you deploy the EV ARC next to an existing, or new if you want to put one in, an accessible parking space with the chargers within the right reach limits of they're at the right height already, they're at the right reach limits on the unit. And we'll help you with this, just deploy it such that it is in a location where it is accessible from an accessible parking space. And under those circumstances, yes, you are ADA compliant.
And that's all the questions we have for today.
Well, excellent. Listen, again, thank you all very much. Thank you for being customers. But beyond that, thank you for what you're doing. I really genuinely believe this is a fantastic move for this country. Having everybody using electric vehicles, not relying on carbon fuels, the climate, if you care about that, you don't need to. This is an excellent economic move too. I mean, there's been countless studies now to show that fleet vehicles, which are electric fleet vehicles, which don't require liquid fuels, don't require the maintenance schedules and everything else like that, offer a lower total cost of ownership, particularly when you're using electricity that has no unit cost for the electricity. There's no utility bill to pay. That's a really, makes it even better. So thank you very much for what you're doing. Thank you for being customers. By the way, I just reminded myself, there's one other thing I should have mentioned to you. Most of the EV ARCs that we ship are grid connectable. You can plug them in. So back to that red light question. I just want to go back to that for a second. Check with us, but it's very likely that your unit is equipped with what we refer to as a shore power connection. This goes back to my days at sea. But at any rate, you can actually run an extension cord out to an EV ARC and plug it into a 120 volt outlet if you see that red light. And what you're going to do there is you're going to augment the solar supply with some grid power. You don't need to run a special circuit out to or anything like that. You can just plug it into an extension cord. And although that extension cord is only bringing out 120 volts and let's say a kilowatt, what it will do is it'll trickle feed our batteries and it'll allow you to operate that level 2 charge off there. You don't need to do that. You don't have to do it, but it's just another option with the product in the event that you are facing a lot of inclement weather or your charging demand is greater than the solar resource can keep up with. You could try plugging it into an extension cord or even running a 120 volt circuit to it. That's another option. And that would just augment the unit's capabilities. I should have mentioned that earlier. Apologize. And again, if you've got questions about that, just get in touch with us and we can give you an update. We do have some useful videos on our website now. There's a sort of an FAQ section. We're adding to those all the time. I encourage you to go to the website and take a look at those. If you want the link, just get in touch with us and we'll send you the link. And those videos will just answer a lot of the kind of questions that you just asked, the red light, how should you use the unit and all that sort of stuff. I talk quickly. I love what I do. I'm very excited by what I do. And so if you missed anything that I said here, a good deal of it may be captured in the videos that we have, the kind of FAQ type videos designed to answer these sorts of questions. So please go to our website, beamforall.com, 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 and then you'll be able to navigate through that, and you'll find the FAQ section and the videos there that should hopefully answer a lot of these questions. Otherwise, get in touch with us anytime you can. So again, thank you. We're delighted to have you as customers. Thank you for helping us to grow this American company. We manufacture here. It's a made in America product. We're very proud of that. I can, as a public company CEO, I get a lot of advice. Why don't you do this overseas? Why don't you make it in Asia? Well, because I'm determined to show that we can do this in the United States of America, put American workers to work in these new technologies and do it better here, more efficiently than we can do it by offshoring all of this sort of stuff. So thank you. We wouldn't exist if it wasn't for you, the customers. We've advanced the technology. We've done things that people have been telling us were impossible for a decade now. We couldn't have done any of it if it wasn't for you, the customers. And again, those of you who are waiting for the product right now, thank you for your patience. We are doing everything that we can to ramp up as quickly as possible. As you saw downstairs, nobody's slouching around here. We're not ignoring you, and we'll get to you as quickly as we possibly can. So thank you, all the best, and stay in touch.